What's up, guys? Welcome back to another weekly live stream of SAT Khan Academy practice problems. So we're continuing back through the topics under the testing section. And what we're doing now is we're basically going back to recanvassing all the practice problem sections under Khan Academy. So if you look up here, this is where I'm going to. I'm going to the Khan Academy SAT section under the math section. We're looking at practice problems and we're going through the level 2 problems. We've already done the level 1 on my YouTube channel. You can check that out. So now we're going back into today linear inequality word problems. And if you're preparing, you probably know they're big on word problems now, big on decoding this stuff. So without further ado, let's jump right into it. So it says members of the wrestling team are planning to sell pre-ordered programs at matches. The cost to print the program is 150 plus 50 cents per program. I'll just say 0.5 times P. They plan to sell the program for $2. Okay. If the profit is the amount of money, if the profit is the amount of money earned from selling programs, right? So this is the cost. Is the amount of money earned from selling programs 2P minus the expenses of printing the programs, which is this. How many must they sell to make a profit of at least $500? All right, so this is basically our setup. Now we just got to solve for P. So I'd say 2P minus 150 minus, we're going to distribute that negative to both of these guys. It's just like a negative 1. 0.5P is greater than or equal to 500. 2P minus 0.5P, these guys combine as like terms to be 1.5P minus 150 is greater than or equal to 500 plus 150, right? I'm just isolating, so we got to get rid of the 150. We're adding it to both sides. 1.5P is greater than or equal to 650. We divide both sides by 1.5. This is a calculator question, by the way, so we can use a calculator. I'm going to try not to. So we've got, I believe P is greater than or equal to, let's see how many times this goes in, 400, and let's just do the division here, 6500 divided by 15, 4, 60, 50, 3, 45, 503, so it's 0.333, goes on forever. So in order to make a profit, now they have an interesting thing. They have 433 and 434. To make a profit of 500, 433 is too small. It won't cut it. We said we have to be at least 433.3. So if we're going for a whole number, they need to sell 434. And that is the answer. So that's the question of whether we round up or round down. You may instinctually think, oh, we round down. But that's a case where the 433, even though technically you're meant to round down when it's less than 5, that wouldn't cut it. That wouldn't be the right amount. Next question. Christopher has at most $18.50. Let's write it over here. Has $18.50 to spend. At a convenience store, he buys a bag of bananas for $1.50 and a bottle of apple juice $1.55. If gasoline at the store costs $2.35 per gallon, look what I'm doing. I'm just adding up all the costs. This is the banana. This is the apple juice. Right? And then here's the gas per gallon, but we don't know how many gallons. Which of the following gallons can he buy for his car without exceeding his budget, meaning we got to be less than or equal to this? Now we just solve this equation. 1.5, these are constants, plus 155 is 3.05 plus 2.35G is less than or equal to 1850. I'm going to subtract 3.05, subtract 3.05. We got 2.35. This is also a calculator problem. Is less than or equal to 15. I'm sorry. 16. Oops. No, it is 15. Had it right the first time. 15.45. And then we divide by 2.3. Divide by 2.3. Let's see. Should I just use a calculator? I think I will. So 1545. Oh boy. What did I do here? That didn't mean to do that. I don't even know how to put this back in. All right, well, we'll just do it like this. 1545 divided by 2.5 equals 6.18. Oh, wait, that didn't work because, 1545 divided by 2.35. I don't know if that'll make that much of a difference, but 1545. No. Yeah, 2.35. Okay, well, I had the numbers wrong. Let's see if this works. 1545 divided by 2.35. Divided by 2.35. Uh-oh. Okay, so something happened. Oh, no, I get it. So this is the exact amount where we'll be without exceeding his budget. All these are greater than that. All those exceed his budget. So 423 is the only one. This is a weird question because it actually has to be the lowest number. Otherwise, there would be multiple answers that would be right. Like if 761 worked, obviously 423 would work. And because it doesn't say what's the most gas he can buy before exceeding his budget. It just says which one can he buy without exceeding his budget. It's actually not a good question because it has to be the lowest value with this wording, which is weird. But anyways, that's kind of strange. Otherwise, I think I had the numbers right, but maybe I made a mistake as to why they came out the way they did. But that was pretty straightforward. Let's go on to number 3. Jonas is traveling by bus to visit a friend who lives 300 miles away. The friend has asked Jonas to call at least 30 minutes before arriving so he can pick up Jonas. Okay. Jonas's bus travels at a constant speed of, I'm going to write this down because I think we need it, distance equals rate times time. He travels at a constant speed of 45 miles per hour, which inequality shows the number of hours T, the number of travel hours T before Jonas should call his friend. So, remember distance equals rate times time, right? So he's going 300 miles. He's going at 45 miles per hour. And for a certain number of hours, we don't know what that T value is. But we can solve for T just by this, right? So basically, let's divide both sides by 45, divide both sides by 45. And we will get at least the trip for the entire length of the trip. So this we can divide both by 5. Actually, you know what? We can do a lot here. But I'll start by dividing. I'm going to divide top and bottom by 3 to make this easier. This will be 100. And we're going to worry about this in a little bit. He says, actually, you know, worry about the inequality later. I just first want to calculate how much time this is going to take. So we divide the top by 3, bottom by 3, top by 5, bottom by 5, which is 20 over 3, which is 6 2/3. So 6 2/3 hours is how long it's going to take. But what is that in time? That means it's going to take 6 hours, and 2/3 of 60 minutes is actually 40 minutes. Okay. So that means the entire trip's going to go there. So when should he call him? He should call him earlier than or less than 6 hours and 10 minutes. Okay. So he should be calling travel hours. So T should be less than or equal to 6 hours and 10 minutes. Or if we want this in hours, how do we translate this? 10 minutes is what fraction of an hour? It's 6, and this is actually 1/6. So T should call at least 6 1/6 hours. So it's one of these two, but we said it's less than or equal to, which is why this gives us A. Because, again, it's very important to recognize that T is the travel hour. So he should call no later than after traveling for 6 hours and 10 minutes. All right, let's go to question number 4. And don't forget, like I said, I'm always doing these problems. This is the first time I'm doing these problems. This is what makes it fun. So I'm actually reasoning it out live with you guys, which makes these, I hope, more valuable. And if you like this stuff, don't forget to definitely subscribe. We do this every Wednesday. Plus, there's all sorts of other good stuff on this channel. Next, we got one particular hotel in the downtown area costs $90 a night. An additional 10% tax is added to the original cost of the hotel room. The way we represent an additional 10% is like this. It's 1.1. 0.1 is 10%. And then if we're saying 1.1, that means we're adding that back to the original 90. 20% tax, we multiply by 1.2, so on. There's also a one-time $12 parking charge. I don't even really know what the question is asking yet. I'm just kind of tabulating everything and being like, okay, well, this is my full cost of this hotel. 10% tax on top of $90 a night plus another $12 parking charge. And a family can expect to spend $30 on tips on their stay. That's another $30. How many nights can a family spend at the hotel without exceeding their budget of $600? So this is every night times number of nights, which we could call X, without exceeding their budget, meaning less than or equal to 600. This is all about just setting up the equation. Once we set up the equation, we solve for X. It's not so bad. But now, just got to evaluate. And this is a calculator problem again. So it's actually, but I'm going to try and do it without. So 1.1 times 90 is actually 99. 12 times plus 30 is 42. I'm going to add these guys. That's 141 times X is less than or equal to 600. We're going to divide by 141, divide by 141. And X is less than or equal to 4. Let's see. I'll just do the division here. I don't feel like pulling up my calculator. So it's 4 is 4, 5, 64. And that is 36, 360. And then that is 4.2. So that is 282. I think this is going to be about enough. So they can, so how many nights can a family, wait, did I do this right? Because they can't even spend 5 nights there. Wait. I did this wrong. Spend $30, a one-time charge of $12. Whoops, I messed up. This $12 charge is actually not multiplying. All right, I got lucky because they could have tricked me and they could have put one of those answers there like 4. But they didn't. I wouldn't have caught that mistake. So that's a nice mistake that I just caught. The one-time charge, the $30 is in here, right? Plus 12. That's not multiplied. We paid $12 one time. Man, I missed that and that was bad. So now we do it again. 99 plus 30, which is 129x plus 12 is less than or equal to 600. Subtract 12. We got 588, 129x. And then now it's 588 divided by 129. You know what? Maybe we should use a calculator just to be faster. 588 divided by 129. 588, whoops, divided by 129. Yeah, this is not a pretty 4.55. You know what? That also doesn't work. So I must have still made a mistake. So I gotta go back again. So it says $90 and additional 10% tax added to the original cost of the hotel room. So a one-time parking charge during their stay, not each day. So the $30 also comes outside. Whoops. So this is also 30 over here. So it's 99x plus 30 plus 12. Now I'm getting it. Took a few times. So that's during the entire stay. I guess it's not affected by their day, which doesn't really make sense because the tips would increase based on technically really like how much time you spend, but I misread that. So now 99x is less than or equal to 558, and this divided by 99. Now we can see it's clearly going to be 5, but let's do the division. 5.8 divided by 99 is 5.6. Now this is a question you might think to round up, but we got to round down because if we round up to 6, we're going to exceed that budget. So it's actually, this is another case where we got to think. We don't want to exceed, so we need to round down. It's going to be 5. And last question, question number 5. An audiologist is testing a patient to determine the softest sound of a specific frequency that the patient reports hearing. She began with 10 decibels for sound for trial 1, then increases it by 2 decibels for each trial after that. So we'll just do a quick table. 2, 3, so it'd be 12. Then it's 14. It goes up by 2 each. If the patient can hear all sounds of that frequency that have a volume louder than 26, so 26 or greater, T represents the trial numbers that the patient can hear. Which of the following inequalities best models the situation described above? So let's see here. The number of trials is 2t plus 10 And so we're talking about, so it's got to be greater than or equal to 26, and I think they all are. Okay, so they all are. Wait, have a volume louder than 26. So we don't want greater than or equal to. It says louder than 26. So by the way, we can eliminate A and C right off the bat. It's got to be B or D. So the question is it B or is it D? Now, we can, there's different, we can actually create the equation if you want. But I think another way that we can think about this is at what trial is 26 decibels going to happen? And if we can figure that out, then we can start to actually, we can quickly plug in a value and see what comes out of B and D and see which one makes sense. So we want to think about it. I'm going to actually map it out. 4, 5, 6, 7. We can come up with a formula, but I just want to show you 11, 12. So let's think about this. This is going to be, so trial 4 is 16, trial 5 is 18, 20, 22, 24. Here's trial 9 at 26. So basically, our this should be at trial 10 and after is where we're actually hearing what's going on. So if we plug in a 10 here, we get 20 plus 10 is 30. Now, this actually doesn't work because if we plug in a 9 here, we get 18 plus 28, 28 greater than 26. Yeah, but this is not an accurate representation of where we're at the 10th trial. It's where we're at the 9th trial. What about this guy? If we plug in a 10 here, we get 10 minus 1 is 9, times 2 is 18, plus 10 is 28, and that's the right amount of decibels. So we can see just from that quick application that D has to be the correct value. And that one is also correct. So that's it for today's live stream, Linear Inequality Word Problems. Again, if you like what you see and this is helpful for you in your preparation for the next upcoming SAT, make sure to subscribe. And make sure to check out scalarlearning.com as well if you want our multiplication mastery course. It's a $20 value, but if you come and you sign up for our newsletter, you get that absolutely free, no strings attached. Thank you guys so much for joining. I hope this was helpful. If you have any questions or comments, please leave them below. Thank you so much, and I'll see you guys next week. Take it easy.